Alright, in our continuation of Algebra 2, we're in Chapter 4, Section 4, and we're only going to do half of the section in this little lecture. We're going to look at least common multiples. Greatest common factors, which is the other half of this section, will be picked up in another lesson. So least common multiples is our objective today. The definition of a least common multiple. The least common multiple of two or more integers, or monomials, is the least or smallest positive integer or monomial that has each of the integers or monomials as factors of itself. That definition may not be helpful in how to accomplish this, so let's look at a strategy. Step 1 is to factor each of these integers or monomials into its prime factorization. If you forgot what prime factorization means, that means every factor is prime factored down into prime numbers. Now, that's prime factorization. From there, to get the least common multiple, we're going to take the greatest power of each of those prime factors, and for variables, we're going to take the variable with the largest exponent, multiply them together, and that'll give us the least common multiple. But before we jump into least common multiples, let's look at step 1 of this strategy, in case some of you have forgotten how to do prime factorizations. So let's start out with the prime factorization of just a number, 180. We might say that that could factor as 10 times 18. And then 10 could factor as 2 times 5. 18 could factor as 2 times 9. 9 will then factor as 3 times 3. From here, what we need to do is to look at all our factors that are the same. So we have a 2 and a 2. We want to have 2 squared. We have a 3 and a 3, so that's 3 squared. And then we have a 5. And that's the prime factorization of 180. All right, let's look at another example. This time we're going to do another prime factorization, but we're going to do that of a monomial, so we're including the variables as well. And as you will see, it's the variables are no problem at all. So let's start with prime factoring 84. We might say that that could start out as 4 times 21. 4 could be factored as 2 times 2. 21 could be factored as 3 times 7. 2 occurs twice, so we want to end up with 2 squared. And then 3 is a factor, 7 is a factor. Variables are already in their prime factorization, usually, if they're simplified. We have x squared, y cubed, z to the 4th. So that's our prime factorization of our monomial, 84x squared, y cubed, z to the 4th. We're ready now to start looking at least common multiples. Let's do one of just integers first, and then we'll come back and do a monomial in the process. So here we have three numbers, 4, 12, and 45. We're looking for the least common multiple. We're going to do factor trees, or do prime factorization of each of those numbers. Starting with 4 is 2 times 2. So in prime factorization, 4 is 2 squared. 12 is going to be 4 times 3. And 4 is 2 times 2. So the prime factorization of 12 is 2 squared times 3. For 45, it doesn't matter which two numbers you start with, but if you say 9 times 5, 9 will factor as 3 times 3, and the prime factorization of 45 is 3 squared times 5. Now that we've got them in prime factorization, that's step 1 of the process for least common multiple. Step 2 is to look at this factor list and take the factor that has the largest exponent. Now, as I'm looking at 2 squared and 2 squared, they're the same. If we had 2 squared and 2 cubed, I would have taken the 2 cubed. These are the same, so I'm going to take one of them and ignore the other. It's covered. So I'm going to take the 2 squared. Here I'm looking at factors of 3. I've got 3 or 3 squared. We want to take the one with the largest exponent, so we're going to select the 3 squared and ignore the 3 to the first power. 5 occurs as a factor only once, so that's going to be the largest power of 5, 5 to the first power, which is 5. And these factors represent my least common multiple. So it's kind of like the union of these numbers here. We're taking the 2 squared, we're taking the 3 squared, we're taking the 5. Sometimes we leave our answers factored like this, but sometimes we need to actually find the number itself. So 2 squared is 4, 3 squared is 9. And 4 times 5 is 20. 20 times 9 is 180. So 180 is the least common multiple of 4, 12, and 45 of all three of those numbers. All right, and then for our next example and last example, we're going to find the least common multiple of monomials. So let's start out with step 1, which is the prime factorization. And for 48, we could start that as 8 times 6. 8 we can think of as 2 times 4. 6 we can think of as 2 times 3. 4 is 2 times 2. So for the numerical coefficient, we have 1, 2, 3, 4 of those 2's. I need 2 to the 4th power, and then a 3, and then we keep the x squared, y cubed, z to the 4th. So that's the prime factorization of 48x squared, y to the 3rd, z to the 4th. Let's get the prime factorization of 60xy squared, z to the 6th. 60 we could think of as 6 times 10. 6 could be factored as 2 times 3. 10 could be factored as 2 times 5. So the 2 occurs twice. We have 2 squared. Then we have a 3. Then we have the 5. That's the prime factorization of 60. For the variables, it's going to be x, y squared, z to the 6th. Now the last part is to look at the least common multiple. So we look at the variables. Given a choice of 2 to the 4th or 2 squared, we're going to take the factor of 2 with the largest exponent. We're going to take the 2 to the 4th. Then, given a choice of 3 or 3, they're both the same. So we're going to take the largest one, which is 3 to the 1st power, and I know they're the same, so one of them is 3 to the 1st, and we're going to ignore the other one. 5 occurs in one list, not in the other, so that's the greatest number of times 5 occurs once. We're going to select that. Given a choice of x or x squared, we're taking the one with the largest exponent, that's x squared. Given a choice of y to the 3rd or y squared, we're going to choose the y to the 3rd. And given a choice between z to the 4th and z to the 6th, we're going to choose the z to the 6th. So let's try to now simplify that and multiply all our factors together. 2 to the 4th power is 16 times 3 times 5 times x squared times y to the 3rd times z to the 6th. And 16 times 3 times 5 is 240. X squared, y to the 3rd, z to the 6th. So that's the least common multiple of the numbers we started out with, which, if I can fit them all in here, 48 x squared, y to the 3rd, z to the 4th, and 60x, y squared, z to the 6th. Between those two numbers, 240 x squared, y cubed, z to the 6th is the least common multiple. And that's our look at least common multiples. For greatest common factors, which is also part of section 4, we'll look at our factoring lecture.